digital evidence. According to the university study report, the amount of digital data produced by humans and machines will exceed 44 zettabytes by the year 2020. 1 zettabyte equals to 1 billion terabytes. People are increasingly accessing the internet and using it on a daily basis to socialize, send emails, and browse the internet. Most of these activities will produce traces and remain present on users' computing device for many years to come. Most computer users are not tech savvy, so they might think that the deletion of a file erases it completely and forever from their hard drive, but this is quite wrong. Data stored on storage units can be restored even after formatting the drive many times. Although certain tools can be used to further revive hard drive space to make it irrecoverable. This is discussed in later lectures. Even these advanced tools can still leave traces, allowing computer forensic investigators to obtain essential evidence to help them solve criminal cases. Computer forensics involves acquiring digital evidence, sometimes known as electronically stored information. Let me write down here. ACI means electronically stored information. Stored information. I'm writing down these terms here for more. So, from a computer hard drive, what ICI is, from a computer hard drive, a mobile phone, a tablet or PDA or other storage media like CD, here USB thumb drive, DVDs, among other places, is in a systematic way, the ACI, electronic storage information, is to be used in court during trials. And we have digital evidence types here. So we can differentiate between two main types of digital artifacts according who has created them. So for example, user created data here. User created data. So this is user created data here. For example, user created data. This is user created data here. You can see. So let me write this down here. Text. So this is the text, and increase its size. Top. So user created data includes anything created by a user, human, using a digital device. So user created data includes anything, anything created by user. So can you see it? Yes. So for example, these are text files, contacts in phone, for example, office documents, and office documents like bookmarks, spreadsheets, databases, any text stored in digital format. And these are actually, for example, user created data includes audio and video files, digital images, webcam recordings, address book and calendar, hidden and encrypted files, including zipped folders created by the computer user. For example, previous backups, including both cloud storage backups and offline backups like CD, DVD, and tapes. Account details, for example, username, picture, password, login credentials, email messages and attachments, for example, both online and client emails, web page, social media accounts, cloud storage, and any online accounts created by the user. Files created by a computer user also contain metadata. But the metadata could be either produced on purpose by the computer user, for example, author name and email, or generated automatically by the software used to create it. For example, GPS coordination of a specific photo. So these are automatically software created metadata here. For example, GPS coordination of a specific photo, captured camera type and resolution. So metadata should also be investigated thoroughly during an investigation, so as it may contain substantial evidence about the case in hand. Just for note, in Windows operating system, you can view any file metadata by right-clicking over it and selecting properties. Actually, let me end this illustration here. So and selecting properties, however, keep in mind that whenever you access a file under Windows, you are changing some system created metadata, last access date, for example, which should be taken into account during investigation. And we have machine created data here. Actually, let's restore it back. So machine created data. Or let's use computer. For example, machine or computer created data. What this data is, I will explain you here. So these data, for example, machine network created data includes any data which is auto-generated by a digital device. Computer created data is any data. Data includes any data here which is auto-generated, by a digital device, So these are computer logs. Actually, these are computer logs here. For example, these includes the logs under Windows operating system, like application security setup, system forward events, application service logs, and we have router logs here. Router logs including third-party service provider, ECP's logs here. We have automatically generated logs, or user web browsing history here. For example, configuration files, we have auto-generated logs here. Browser data. This is not the history data. This means cookies and other datas. For example, we have GPS tracking data. For example, this includes photo metadata, GPS. For example, we have application history. For example, temporary files, we have here temp files, email header information. This means metadata. So metadata is everywhere actually. Registry, reg files, Windows. The reg files are in the Windows only. For example, bad clusters. Well, I will talk about bad clusters in later lectures. For example, memory dump files. For example, virtual machines, and these are enough. So we can summarize digital evidence as any kind of file or metadata that is presented in digital format, binary format, and could be used during a trial. Locations of electronic evidence. Actually, this here. So actually these are all lectures. Actually, this is not all lectures. These are another tech means another course lectures here. Ethical hacking lecture that we created. So for example, location here, location for better illustrating the here location. Locations of electronic evidence. Here, location of electronic evidence is here. Let me actually do it and I will explain all of this here. So left top and increase the size of this little bit. So digital evidence is commonly found on hard drives. However, with the continual advance of computing technology, digital evidence become present in almost all digital aware devices. So now where locations of electronic evidence is, for example, desktops, laptops here, or tablets. This includes any digital device, or actually let's add phones, for example, servers and RAIDs here. We have network devices like these are hubs, routers, for example, modems, switches, and others. Here we have, for example, Internet of Things devices, IoT devices, and DVRs here. For example, we have almost digital evidence everywhere. MP3 devices, for example, pagers, digital voice recorders, for example, printers, scanners, external hard drives, for example, copiers, or for example, smart cards here, and other digital evidence here. Just for note, there are different sources of digital evidence, and each one requires a different method or tool to acquire it. So the focus of this course will be on acquiring digital evidence from computers running Windows, operating system Linux, or we will acquire the digital evidence also in mobile phones like iOS, Android devices, and we will almost do all the acquiring practical evidences from all digital devices. So what is the challenges of acquiring digital evidence? Actually we can close this now. So criminals use different ways to frustrate digital forensics examiners by destroying and hiding their incriminating activities. So also seizing digital evidence is subject to different laws across states and countries. So in next lecture, actually let's do it in this lecture. So what is the digital evidence acquiring? What's the challenges of digital evidence occurring. So the first is one is locked computer with a password, access card, or dongle. Then digital stenography techniques to conceal criminating data in images, videos, audio files, file system, and in a plain sight. Encryption techniques to obscure data, make it unreadable without the password. Then we have full disk encryption, FTEA, including system partition, for example, BitLocker drive encryption. Strong passwords to protect systems. Volume cracking them is very time consuming and expensive. So these are the challenges of acquiring digital evidence. And we have lots of challenge in this field. For example, file renaming and changing their extensions. For example, changing docx file into DLL, which is known as the Windows system file tab. So the digital forensics will not know, actually, it's suspicious. Attempts to destroy evidence through wiping the hard drive securely using various software tools and techniques, or actually physical techniques we have here as well. Removing history from the web browser upon exit and disabling system application logging where available. And then we have as challenge physically damaged digital media. For example, we cannot retrieve deleted files from a filed hard disk drive before repairing it. For example, we have labs covering the collection of digital evidence and device seizure, which is different from one state to another and between one country and another, of course. So cybercrime can cross borders easily through the internet, making the lack of cyber life standardization a major issue in this field. For example, sensitivity of digital devices, if not handled carefully, it might be destroyed. This means heat, cold, moisture, magnetic fields, and even just dropping the media device can destroy it. The usually of the data ownership. For example, if investigators captured a USB thumb drive that belongs to a suspect, but the data inside it is fully encrypted and protected with a password, so the suspect can deny it ownership of this thumb, making the decryption process very difficult to achieve without the correct password key file. The techniques mentioned in this mentioned briefly here and to frustrate computer investigators will be described in next lectures. However, keep in mind that the majority of criminals are not tech savvy, so these people will not employ advanced methods to cover their tracks, even though some of them may use different privacy techniques to cover their files and activities on the computer. The majority will not implement them 100% correctly, and this will leave a door open for examiners to do their job and break into acquire valuable information from the suspect computing device. Who should collect digital evidence? So digital evidence should be examined only by trained professionals who have the expertise and knowledge to handle sensitive data without destroying it during the investigation. These investigators should have for general skills. For example, these are analytical thinking. This includes the ability to make corrections between different events, facts when investigating crimes. And then we have he or she needs to have solid background in IT knowledge. This includes wide knowledge about different IT technologies, hardware devices, operating systems, and applications. But this does not mean that an investigator should know how each technology works in detail, but he or she should have a general understanding of how each technology operates. Hacking skills. The digital evidence collection should have hacking skills. To solve a crime, you should think like a hacker. So knowing attack techniques and cybersecurity concepts is essential for successful successful investigation. And the digital forensics evidence collectors should have communication and organizational skills. An investigator should have documentation skills to organize his or her findings and present them to other members of the team and attorneys and judges. And he or she needs to have understanding of legal uses concerning digital crime investigators. Also needs to have excellent knowledge of technical skills related to digital forensics, like data recovery and acquisition and writing technical reports. And also have he or she also needs to have online searching skills. So and the ability to gather information from publicly available sources, for example, open source intelligent here. Sometimes a digital forensics professional will play the role of expert witness in court law. What differentiates an expert witness from a non-expert witness on conventional witness? The typical witness will testify on what he saw or heard, while the expert witness will have the opportunity to give his or her opinion to the court. Judges and jury are not always familiar with the technical details associated with digital crimes, so an expert witness should help them to assimilate and understand these technical details. An expert witness does not have to hold an advanced academic degree to testify. However, he needs to show a proven technical ability to clearly demonstrate he fully understands the subject he is going to testify about. To make expert witness testimony effective in court, it recommended that the expert have the ability to convey complicated technical details for something easy to assimilate by non-technical people like judges and jury members. Often such people work in the teaching field, and authors can play this role very well.